In this video, I'll show you two examples on how to use transformations to graph quadratic equations in vertex form. The question reads, use transformations to graph y is equal to negative 2 times x plus 2 to the power of 2 minus 4. The vertex form gets its name from the idea that you can derive the vertex of a parabola simply by analyzing the equation itself. So for instance, in our equation here, this is in vertex form already, and all vertex form equations take on this form: y is equal to a bracket x minus h squared plus k. The h and k value of our equation tell us the x and y coordinate of our vertex, but it's not as simple as you may think. The easy one to locate here is your k value. K is negative 4, and k represents the y coordinate of the vertex. So I'm going to write down vertex, and my y coordinate I know for a fact is negative 4. The next one is h, and you can quickly jump to a conclusion that your h is positive 2. But you'll notice that your vertex equation and the template for a vertex form is slightly off. In the template version, the h has a negative in front of it. Ours does not. So we have to change ours so that it has a negative in front of the number. How do we change a positive into a negative? Well, it's not that hard. I can change this part right here into minus negative 2. Minus negative 2 is the equivalent of positive 2. So now if we were to match our two formulas here, our h is definitively negative 2 because we have a minus now, and that's originally minus, and our h represents the number. In our case, it's negative 2. So therefore, our vertex lies on negative 2 and negative 4. Now the reason why that's important is because what's represented here in red is y is equal to x squared. And y is equal to x squared has a vertex at 0 and 0. So our new vertex will be at negative 2 and negative 4, and that can be located here. Negative 2 over to the left and negative 4 downwards is exactly here. I'm going to write down negative 2 and negative 4. Once you have found your vertex, your next step is to identify your a value. In our case, our a value is negative 2. Now we learned that when your a value is either greater than 1 or a is less than negative 1, you end up getting a vertical stretch, which means that it will get skinnier by a factor, in this case, of 2. So instead of having one that is as wide as you see in red, it's going to be skinnier by a factor of 2. Now without a table of values, it's going to be hard to show a skinnier parabola than this. The best way to approach this is to first find out what the y-intercept will be. And by finding out what the y-intercept will be, you will know where to take your parabola from there. And to find our y-intercept, we simply set x is equal to 0. So negative 2 times 0 plus 2 to the power of 2 minus 4. This goes to positive 4 minus 4. This goes to negative 8 minus 4 is negative 12. So our y-intercept is at 0 and negative 12. Let's see if we can locate that on our graph. Unfortunately, we can't, since this goes to negative 10, but we can assume that it's going to be here. So what we can do next is connect this point with that one. And since our a is negative, we know that there's going to be a reflection. In other words, our original parabola, which is facing upwards, will start to face downwards. That being said, I can find the distance from here to this point, which is a distance of simply 2. And our other point will be here, because I'm adding 2 to negative 2, and that goes to the left. And all I have to do now is connect this vertex with that point, and I am done. What you see in purple actually looks a factor of 2 skinnier than what you see in red. So let's do the exact same thing that we did in this example for question 2. In question number 2, they ask, use transformations to graph y is equal to negative 0.5 x minus 3 squared plus 5. We'll start off by identifying our vertex. Our vertex will be at a y coordinate of 5 and an x coordinate of 3, because this right here represents our h. So we have a vertex at 3 and 5, and let's plot that. 3 and 5 is over here. My next step is to identify my A term. My A term is negative 0.5. This negative tells us that our parabola will be facing down, unlike this one, and it will experience a vertical compression, meaning that it will get fatter than this by a factor of 2. Now, how are we going to show that? Well, we'll use the same technique as before. I'm going to find my y-intercept by setting this equal to 0. So let's do that. Y is equal to negative 0.5, 0 minus 3 to the power of 2 plus 5. Negative 0.5 times negative 3 to the power of 2 is positive 9. Multiplying these two numbers out, I end up with negative 4.5 plus 5, and that is equal to 0.5. So my y-intercept is at 0 and 0.5. So it will cross somewhere here. So I'm going to connect these two together. Now the distance from here to here is 3. So the same distance will apply to the right of it. So we're going to have another point at 6 and 0.5. Because remember, a parabola is symmetrical. And from here, all you have to do is continue with the trend and show that it is a continuous function by putting these arrows. Because if you want to be entirely exact, you would have to use a table of values. But they're just asking us to use our transformations to do our best to sketch the equation. And there you have it. That is how to use transformations to graph quadratic equations in vertex form. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.